Thank you everyone for being here. We are really glad to be in Vegas. I'm traveling from France. So I'm Thomas. I'm Mehdi. And some few points before starting. First, as we are French, please excuse for our broken English. That's the first point. The second point is who we are, basically some auditors in information security response incidents. We have several years being professional, so that's it. What is the agenda today? So briefly, we will introduce you. Let me ask you something first. Raise your hand, who's familiar with Hadoop? Who's ever heard about Hadoop using MapReduce? Cool, so a lot of people, that's great. So we'll be moving on quickly from the first part to the second. In the first part, we will introduce briefly Hadoop and its security model and to understand what are the known limitations. And then from the second chapter, second section, we will be reviewing how can we prune and what are the different steps in order to assess the security of a Hadoop cluster. There's some few points, few tricks, and by the end we will be giving you some recommendations as we have been auditing and penetration testing several Hadoop clusters, mostly for French clients, but we've got some realization on that topic, so we can guide you and give you some, I hope, good advice. So Hadoop, what is Hadoop? Hadoop is an open source framework that allows for the distributed processing of large data sets and using simple programming models. For the distributed processing, you know the MapReduce algorithm. At the beginning, it was invented by Google in order to sort and index web pages, large amount of web pages. Here is the principle. I won't be detailing it, but you can see that you have different phases: mapping, shuffle, and reduce. The goal is to sort some stuff using a lot of different nodes by grouping them on the key. That's the first one. Then for the open source point and characteristic of Hadoop, Hadoop is now backed from Apache, from the Apache Foundation from several years now. It's completely open source and free. But in real life, Hadoop environments are gathered in distributions just like Linux. The current three main distributions are the following: so Cloudera, Hortonworks, and Mapper. Really, in real life, you find 80% of clusters, let me check, where's my, 80% of clusters are either Cloudera or Hortonworks. Cloudera has some proprietary stuff. Hortonworks goes full open source with only open source products and a cheaper license fee. And Mapper is doing Hadoop without Hadoop, to be fair. They are fully understood what the Hadoop limitations in terms of performance are, and they are trying to bypass this kind of limitations. We will be talking about the name node limitation just after. They fully understood the case, and they are doing Hadoop without really Hadoop. Hadoop is just a connector for some stuff. But in real life, we are mostly viewing some Cloudera or Hortonworks distribution. The common point is the use of the Apache Hadoop core framework, which is doing mostly only two stuff. Basically, Hadoop is what? Storing a large data set and processing large data set. That's the only point. In real life, what does a real big data environment looks like? So at the beginning, you're buying a lot of CPU, RAM, disk. On top of it, you're putting the Hadoop core in order to support the data lifecycle in the platform. For the acquisition, here are some different modules. You will see different modules that will appear in this slide. For acquisition, you have like relational or non-relational databases. And most importantly, you have HDFS, which is the distributed file system in order to store large data sets. Then for the processing, you have a lot of modules, really, different modules. Maybe the most popular right now are Apache Spark, Apache Drill for SQL request. And on the Hadoop core, you have MapReduce and Yarn. MapReduce, which is the algorithm in order to distribute some tasks, and Yarn, which is a scheduler. Like a plain operating system is just, and it's pretty complicated to be fair, it's just scheduling and managing some resources on the cluster. Then you have some indexation module. I guess you ever heard about Elasticsearch, Solar, Lucene. At the end, you want to consult your data. So you have different modules for end users, mostly web applications, in order to be as friendly as possible. So you have Jupyter, which was IPython notebook, U, Cloudera U, Tableau, SAS, which SAS is a known old vendor for this, Dataiku, Splunk, and so on. For the administration, typically for Cloudera, you have the Cloudera Manager, which is a proprietary product. For Hortonworks, you have Apache Ambari, which is doing all supervision and administration for the cluster. And you have different, for each distribution, like a proprietary or specific management platform. And at the end, because we are here for this today, security. So you can see that security, there's really few modules, and even in these modules, they have already one task, a NOC, which is a gateway, Ranger, which is the central policy management, and you can apply your corporate policies and how to protect data and to put on some ACL. Sentry, which is to be, like one rival of Ranger, but in the end, in real life, tell me after informal, but this is kind of broken and not really useful and not really user-friendly. So that's a bit abandonware. And you have record service, which is coupled to Sentry for the Cloudera stuff. But mostly for security modules, you don't have many stuff. That's the first observation that you can make by looking at the Hadoop ecosystem. Hadoop under the hood, two parts, as I said, storage and processing. So you have some data nodes, which are storing the full data parts. And you have a single active name node, which is typically a mapping list of the file parts. The name node knows for your file, which is divided into blocks, to different subfiles. They are stored among data nodes. The name node knows where you can retrieve the part of your wanted file. For the processing, as I said, you have MapReduce and Yarn. MapReduce being the job distribution of the cluster, and Yarn, which is the scheduler. Yarn is as I said, pretty complicated stuff, and we haven't been digging that much into the security of it. I guess there are some vulnerabilities, to be fair. Right now, you can say, okay, cool, but really, who uses Hadoop anyway in real life? So from the official Hadoop pages, you can find some different providers or web giants using it, and you have an idea of their number of nodes. A node is a server, to be fair, with a lot of resources, CPU, RAMs, and disk. And you can find, Yahoo has a lot of Hadoop nodes, and was a massive maintainer and massive contributor to the Hadoop project.
Okay. Hi, everyone. So now that you master the Hadoop secret, I will present its security model. So first, let's talk about authentication. So by default, there is no real authentication mechanism implemented on Hadoop, or mostly there is the authentication mechanism called Simple, which is implemented by default. So without Kerberos, which is the other authentication mechanism available on Hadoop, the cluster won't verify your identity. So you pass the string, for example, you are HDFS, and the cluster will trust you. So the two authentication mode are Simple, which is just identification, and the other is Kerberos, which is more difficult to implement. So simple authentication is just identification, and you can be whoever you want, which service you want. You can perform any action with any username that you want. You just have to provide this name. So to improve the security, you have to implement the sole proper authentication mechanism, which is Kerberos, and which is more difficult to implement on the cluster. So be careful when you activate authentication, because on Hadoop, you can activate partially authentication with Kerberos, and for example, you have the parameter to implement authentication on the whole cluster, just on the core Hadoop, so that's the parameter. But then you have to also to enable the authentication on the web pages, because there is a lot of there are a lot of interface, web interface, which are accessible to the user. And if you do not enable this parameter, you don't put Kerberos, we will have the simple authentication activated on this service, and any user could be any other user he wants. But then you can you have to also to activate this parameter, which allow to use anonymous authentication. So you have to disable this parameter, and then you have also to enable this parameter to activate authentication on the Yarn service. So you have to put Kerberos instead of simple on this different parameters in order to activate Kerberos on all the service and not just on the on one of these services. So be careful, and that's a big deal, because we have see several times authentication enabled, but not on every interface. So that's
so in the end, it's like simple authentication is like deployed, and you can access and be whatever user you want. So be careful. That's the first strong point for Hadoop security. Remove all simple auths, and that's not just one parameter. That's a bit tricky, but that's the first trap not to fall into.
So we will show you some attack, etc., based on this simple authentication. So next, authorization and auditing. So as we will show you, there is, and as Thomas already showed, there are a lot of service components on the Hadoop cluster, and each of these components implements one authorization or one auditing model. For example, you have the HDFS, which is this Hadoop distributed file system, which implements POSIX permission with extended SAL, like on Linux. So you can have a user, a group, and other, and you can set permission for these different people, and also use SAL since the Hadoop 2.5. Then you have, for example, Hive, which is a SQL DBMS on Hadoop, which implements authorization on SQL Server. For example, you can grant access with select to one user, and you can grant delete to another user, and perform authorization model on using this SQL Verb ACL. So with these two examples, you see that there are two authorization model for two components, and that's the point. You have a lot of authorization model. It's difficult to manage. So in order to manage, you have some third-party components which are used in order to manage all these authentication model and to centralize this management in order to simplify the administration. And these components are also used to concentrate to the security and the audit policy and the security logs. For example, you have the Apache Ranger that Thomas already talked about, which is the only serious component used for security feature, which allow auditing centralization, log centralization, administration of the authorization model, deploying of Kerberos, etc. And it's only packaged with the Hortonworks, which is the most open source package that you could use. And then you have also Apache Sentry or Cloudera Record Service, which come with Cloudera cluster, but which is not as mature as Ranger is. So for the moment, the only strong third-party module is Ranger. On Sentry, you can perform something, but it's more difficult to administrate, and it does not implement all the capabilities of Ranger. So next, data protection, as the cluster are often used to store sensitive data. It's an important feature. So you have two encryption features. You have encryption in transit. It's when the encryption of the flow of data, and encryption at rest, which is encryption on storage. So these two encryption are available by default on the Hadoop, but you have to implement Kerberos in order to activate them. So encryption in transit for the communication with the name node, which is the node which holds the index of the file, etc. You have a three-level protection mechanism used on RPC chain and SASL mechanism. So you have the authentication only, which is no encryption, but just authentication. Then you have the integrity setting, which is authentication and integrity. And you have the privacy, which is full encryption, including authentication and integrity. For the communication with the web interface, you have also by default the capability of activating SSL and TLS on this service, but it's not activated by default. Then, for the communication with the data node, sorry, it's pretty the same that on the name node. You have a data transfer protocol which involves two-phase key exchange using 3DES and RC4, which are not the strongest algorithm we know, and encryption, which is used by iOS algorithm using a different size of key, default 128 bits. Then you have the encryption at rest. Hadoop implements its own encryption model, which is based on two key, which is the encryption zone key used to encrypt the directories on the cluster, and the deck key, which is the encryption for the file. Okay, so you have this scheme which show you the minimal architecture. So you have the name node, you have the clients. You have the name node, you have the clients, and you have the KMS. The name node stores the IDEC key, the KMS store the deck key, and there are the clients. So you ask for the name node for the IDEC key, which asks the KMS, which holds the ACL. If you are allowed to access the key, the KMS will give you the decryption key. You can decrypt and then manipulate the file and store it after. So here you can see that the security boundary is not the crypto system or not related to cryptography, but just on the SEL and the robustness of the KMS. Because the KMS holds the key. So if you can pull the KMS, you can access to all the key and decrypt all the data. So it's not a crypto problem, but it's just a robustness of KMS. That's the boundary.
Just one word about the cryptography. You may ask, what is the overhead and what are the drawbacks of using in transit and at rest? To be fair, there's no really much overhead using in transit. This is pretty much encryption, known with SSL TLS. You have no performance impact, but to be honest, for at rest, you have some performance impact. In the documentation, they are speaking about at 20%. I think it's pretty correct. It's 20, maybe even 30% of performance wasting, I would say. But that's the price to pay today in order to have encryption at rest. For defenders, be careful again. This is not the first action you put. Encrypting the data lake is not the very first action you have to implement. In most of the cases we've seen, encryption at rest is really mandatory for some regulations. I guess you have some, and you have some in the US, but this is, to be fair, not the first point and not the first security measure to put in place. No encryption at rest in the end. But for in transit, this is pretty much mandatory, and this is really common.
So for the next part, we will talk about the mapping the attack surface on the Hadoop.
So as we are entering the second section, which is focusing on the attack techniques, to be fair, there's not much. We will see some defensive measure after, but the point of that talk is really attacking, how you can attack a cluster and improve its security in the end. From our experience, an Hadoop deployment commonly follows one of the three following topologies. So as an attacker, know your environment, know where you are, and know in which case you are conducting your assessment. So first, you have the simple topology, which is everything is exposed on the corporate network. You are plugging into meeting room, and you can access the infrastructure is really exposed on the corporate network, I guess. So you have you can find just on the flat network and flat topology, you have some edge node. What is an edge node? An edge node is like a bastion. It's like a unique entry point to a cluster. This is basically what an edge node is a Linux server offering. You have to connect on this with SSH and just offering, the Hadoop native client in order to perform some actions that we'll see after, like Hadoop list me some file at the /path and so on. This is for Hadoop users in order to have their working environment, standard, and having the same binaries and having the same version, and not administering and releasing your action from your own PC with different version and so on. Then you have the name node. You understood that the name node, it is a single point of failure, because without name node you can't access anything on the cluster, and you have some data nodes storing the data. So as you may understand, this represents a wide attack surface. You have high probability of pulling some stuff and in the end accessing some data on some resources. Then you have the second topology, which is a bit better, where you expose only necessary end-user services, because in the end, on your cluster, you don't have many use case, and you don't have, from a security point of view, it's not good if you have multiple entry points and multiple ways to access a cluster. So in that topology, you only have the edge node and some web apps for consultation. So Cloudera U, Jupyter, IPython notebook, Zeppelin, which is the open source version of Jupyter, not an open source, not an open source version, but another open source version for the same usage. You have a notebook, you can input some commands and retrieve some data from different data sources. And then you have the internal Hadoop network. That time, you can see data node and name node are not exposed on the corporate network. That's a bit better. So in that topology, the attack surface is really reduced, to be fair, because as an attacker being plugged on the corporate network, you won't see much stuff. And you must, in the end, exploit trivial or default credential on these services, or web vulnerability on the web apps, which exist, by the way. And the last and the most restrictive topology, which is the highly segregated version and from the corporate network, you have a unique or true unique access point, which can be Citrix or Bastion and whatever. I won't quote some brands, but you understood the idea of having one dedicated entry point where you can implement logging stuff, DLP, and so on. Then you can see from that Bastion the front-end Hadoop network, which are, again, the edge node and the web apps for the end users. And you have the backend, and imagine there are really some firewalls between each network, implementing some granular access list. And so you have the backend, and from that topology, you can see that in order to access the backend, you really have to first go onto and to access the Bastion, which reduce the probability, and then you have to put some stuff from the edge node of web apps. So again, it divides the probability. So the attack surface is really minimal, and as I said from the first part, you have a unique access point to enter the Hadoop infrastructure, and you can implement some more compulsory measure like logging and DLP.
So the first step when you will try to perform a pen test on the Hadoop cluster will be to map the attack surface. So first, you will see a lot of service if there is no network segregation or network filtering, because as we already told, there are a lot of services available on cluster. You have, for example, the HDFS related services, which are, for example, this service, which is used by the IPC connection. Then you have some web access interface and the web API. For example, this HTTP interface, which are used, for example, to browse the HDFS file system. And then you have also some YARN-related interface, which are, for the first one, the IPC port, and then you have the HTTP port for viewing the log of the YARN service.
Of the task. YARN, as I said, is a scheduler. It just schedules some tasks. From these services, you can submit a task and follow its status.
And then we just put some old stuff that we might not see on the pen test on a new cluster. So then on the data node, you have also a lot of services. This TCP service is used for HDFS data transfer, and it's called when you use, for example, the Hadoop FS dash put command. Then you have some HTTP interface, which is pretty much the same as this one. On the name node, there are a lot of interface that are commonly used on the data node and name node, and which are very verbose, and the same on the name node and the data node. There is no much difference between them. And then you have some YARN stuff also on the data node, for example, on this port. So I will show you some example after. And then you have also some interesting third-party module. We did not put all the module, but some interesting stuff. You have the HTTPFS interface. You have the Cloudera manager, which is used to manage the cluster. You have the Apache Ambari, which is pretty much the same that Cloudera manager, which is used also to manage the cluster. You have the Apache Ranger interface, Cloudera U, etc. So let's see the interface. Like I said before, you have here on the name node the interface. You can browse the HDFS and see the different file, and you can also download. All these interfaces are related with an API, and there are some call with the API, and we will talk about after. We have pretty much the same, but maybe a little bit more ugly on the data node, but it does the same thing. You can browse the data node, browse the name node, and browse the HDFS. Oh, sorry. Okay, then you have the YARN interface, which are used to view the job which are running and the container launched, etc. You have this one. You can see which resources are used for the moment on the cluster, etc. So you can view the history of the YARN, etc. Okay. Pretty much the same. Then it's pretty much the same than the previous one. You have some job history, YARN history, and that. Yeah. Okay. So you can use Nmap, the tool Nmap, in order to fingerprint this service, because there are some
some scripts
which have been developed in order to identify this service. You have the scripts for Ambari, Uzi, etc., etc. The output is like this one, so you can view which service is listening, and in order to cartography the network.
So after you made your mapping, network mapping, what do you want to do to access data? How you would like to do through a browser because you're lazy, really lazy, you want to use your own browser to access anything. So you have to use, and you will be calling in the end, WebHDFS API, which is, as you may understand, how to access HDFS through a web API. It offers a REST API to access data. You can do pretty much everything with WebHDFS. And where can you see some HDFS, web HDFS services? Some first on the HDFS data node web UI that you saw just before. On also the HTTPFS module, which is just exposing web HDFS. And in the end, also on Apache Knox gateway, which is only exposing some WebGFS and some stuff. Apache Knox is a security component, but this is only a gateway, and this is only for network purposes, and how you can filter and put in place just a single entry point for your data infrastructure. So now, what if the cluster only enforces, simple authentication, which is again identification, that you can access any stored data by using the user.name parameter. That's not a bug, that's a feature, and that's an authentication feature. Tiny demo. So here you can see the common interface that you can see a lot of variables data from the configuration. Here, if you go to utilities browse the system, you can browse and access whatever you want. And then can you see the permission denied message 0 saying that by default I'm Doctor Who, and I can access that folder because I'm not the Falcon user. So and now if we can call under the hood of this is just calling the WebHDFS API that you can see here. So here you have your pass on the HDFS. You put on some operation, list status, open, delete, and whatever. And so here I want to access, the /user/HDFS directory, and it says I'm not allowed because I'm Doctor Who. Okay. If there's really some simple authentication and no Kerberos, which is the strong security point, you can input whatever you want, and you can be HDFS, and that this time you can see and access everything. So just by inputting your username, that's pretty ridiculous, but that's a security model. That's why you have to implement Kerberos. This is a strong requirement, and then you can access some data like this, just by saying first we have created a file named BSides, and then you can. This won't work here because of some network stuff, but here I can access the file. This is the next step is to open the file. And now I will just being able to have the complete directory tree on the infrastructure is really useful for attackers because you have to access data in the end. So we've been developing a tiny script that's really, there's no magic in this. It's just automating some WebHDFS call, and you can browse everything. And now, if you want to access data, but through CLI and Hadoop native stuff, you can input the same username, the user.name parameter. You can input it as an environment variable, and here you can see. First, I'm denied because I'm Toto. Then I'm saying I'm HBase, which is a non-relational database, and then I can access everything. That's pretty much as simple as this. You can just maybe doing a slight demo. So you can access this. As I said, HDFS side. That's it, I guess. This is you'll see the first point when you enter Hadoop, you know that you think that big data is really quick and fast. No, that's a joke because everything is in Java. Everything is pretty much slow. So here I can, because I'm root. I can access everything because I'm root. I'm not the correct user to access it. So I will just say that I'm HDFS, just the same as user.name parameter. And that time, I hope it will work. It worked. You can access. There's no magic in here. So that's the first one, being able to access some data on the cluster. But then we have some more interesting attacks, which Mahdi will introduce.
So yes, after you have access the data, you want execute code on the cluster. So remember, Hadoop is the framework used to execute some stuff, some commands in order to sort file, etc., etc. So with simple authentication, as we have see, you can do pretty much everything you want. So let's try to execute some code. So Hadoop is developed in Java. So by default, I would say you are forced to develop in Java, but some people have developed the Hadoop streaming jar, which is used in order to execute any kind of script, Python, Bash, etc., on Hadoop. So the command line is this one. So you have the Hadoop jar. You put the path to the Hadoop streaming jar. You put the input file, which must not be empty. You put the output directory and the mapper, for example, bincat/etc/password, and the reducer none, because we won't use reducer in order to be in order to be faster.
This is just a slight optimization, just because you don't need, for this task, you don't need a reducer.
Yes. So then you try to check if the command have been successfully performed. And then you can read the file, and for example, you have the access to the /etc/password file. So then, like we have seen, there are a lot of steps in order to access the file and the data. So we want to optimize this process. So we will use Metasploit in order to have a real interactive shell. So we will use reverse TCP payload. The reverse TCP payload is generated by the command line in MSF Venom. Then you launch the Hadoop streaming by adding the file parameter, which is used in order to upload the MSF payload, which have been generated before, on the cluster, and then execute it. And you have to execute it with the background parameter in order to not stop the process after a time mark. Because if you don't put a background parameter, your process will shut down after some time mark, so it will be a problem.
Let's have a demo. As it may take some time, we'll launch and we'll go on, and hopefully we will see the shell arrive on our computer. So here, this is my attacking machine. You can recognize Kelly. So here I've all set in order to just to listen for the handler, and then I will just upload and try to execute my not interpreter but reverse TCP for the reason we exposed just before. So I guess it should be okay. This is just sending, the payload. This is admitting the job, submitting token. Yeah, okay.
So job is running on background.
Yeah,
so
job is
you have
running.
just to wait in order to have your connection back. So, but like we said, the Hadoop is pretty slow, and even more on our virtual machine. So we have to wait until.
And here you can, on the PuTTY window, this is the access on the server side. This is just for monitoring purpose for our demo, just to see when the payload gets executed. But normally, as an attacker, you don't have access to that PuTTY window. You're just with your Metasploit and attacking environments.
Wait.
We just have to wait, so we don't know when it would be executed. That's the first point of big data. You don't know when your job will finish. So let's move, and we'll go on just after when we'll see if the shell arrives. Okay.
Yeah, je continue. Okay. Just some limitation about executed code. So Hadoop is a distributed processing model, so you can execute your code on many nodes, and you don't have the capability to choose on which node you want to execute your code. So you will launch a MapReduce job. The Hadoop core will choose on which node it executes the job, but you can't target a specific node. So that's the first point. You can't target a specific node. Then you have to configure your Hadoop client, because we didn't show you because it's not very interesting in our demo. But you have to set up your environment in order to be able to call the Hadoop client. Executable. So you have to retrieve the configuration. In order to get the configuration, you can access on almost on all the web interface, expose the /conf path, and you can retrieve the configuration on this this interface. Then. So you can. There is also some vulnerability on a third-party module which allow unauthenticated user to access the configuration. So in order to,
yeah, our shell arrived. Come on.
So yes, that's a bit long, but our shell arrived, and we are able to execute code on the cluster. So we are here yarn, which is normal because the yarn is the user used in order to execute job. So yeah.
Okay, so that's the first one. How you can access. There's no magic here, as Hadoop just allows to execute some stuff, but if your user is pretty malicious, he will execute a interpreter or something like this.
And on peut peut-être montrer maintenant le truc du you.
Yes.
And we will show you the vulnerability after, but once you are on the cluster, you can browse the data node on which you are, and try to find some file. And we have found that some files are not well protected. For example, on the U interface by default, the U configuration file is readable by anyone. So you can read it, and if you read it, you will have access to the data, the database password used by you. So you could access the hash, the username, etc. But you also can access, once you access the database, to the session cookie. And by listing the session cookie, you can just take the session cookie of the administrator and connect it.
This is one vulnerability we will show just after, but you can see here we're just showing you that when you install you
by default,
pretty much on the same server, and there's a vulnerability. There's 10 minutes left. Mahdi, let's move. Thank you. So
we have developed a script in order to retrieve to automatically retrieve a minimal configuration, which is called Hadoop Snooper. You can find on GitHub, and you just have to launch the script, and it retrieves automatically the configuration for you.
So you can say, okay, that's cool, but come on, we expose this such service anyway on the internet, for instance. With a shutdown request, you can see a nice dork is that port. All the results here are not really Hadoop clusters, but that's a good input in order to find some. So the point is there really are some Hadoop clusters free accessible on the internet. And some figures from a study our own. So as you may understood, what the first point is to say to see if there's simple or Kerberos authentication. So from these figures, I guess you understand that there's no much really clusters with Kerberos implemented. And the other point is the watch out point when we say remove all simple loads from that figures on the right shows you for the 5 Kerberos cluster how many are implementing, are fully implementing Kerberos end-to-end and onto HTTP interfaces. So you can see 0. And again, that's cool, but come on, who's really interested in attacking Hadoop stuff? So in the media, you can find some stuff. There's some ransomware and some people wiping some Hadoop databases on the internet. You can find here. with a slight message, no data for you, secure your shit. They are pretty much encrypting or removing everything, and you have to pay your ransom. And you can find some stuff in the middle. So now let's see how you can put a cluster with intrinsic Hadoop components. So here we are exposing a vulnerability that allows any authenticated user on the machine to impersonate and to steal the identity of the HDFS user. There was a vulnerable call. This is patched now, but for this version you can find a lot of actual and current cluster having that version or below. And here, when you are putting that command, that's the vulnerable command, HDFS groups something, it tries to retrieve the groups for a user, and this is not escaping correctly stuff, so you can see that you can execute anything. And here, you can see that the command is executed as the HDFS. So even to attack Clouderize cluster, no simple out, no tricky, no simple stuff like this. You can, with this vulnerability, go from your identity. You can go from your identity to HDFS. Again, HDFS is the root user on the distributed file system. You can do everything you want on the distributed file system with that user. We are not the vulnerability finders. We just documented the exploit as no stuff has been published. Sorry. Even if Hadoop is fully open source. Some demo time. I will just show you a slight demo, just to say that we are not bullshitting you. Here, sorry, I'll be Toto, another user, and so I'm just trying to input a file, into a /tmp to see that which user is executing this. And now, if I'm just yes, I am HDFS, so I move from Toto, standard user with no privileges, to HDFS. This is the vulnerability, how you can exploit it. How bad is it? The prerequisite is that the shell-based unique group mapping should be used. This is not the default value, and we are not expecting to find much cluster with it. Again, some figures from our study on the internet. You can see in purple how many clusters implement some shell-based unique group mapping. Now you have some vuln on third-party modules, even security modules, Apache Ranger. You can see a nice SQL injection. So you can do two stuff: dump user credential, but they are hashed, so that's pretty much not interesting. And or better, dump user session cookies and reuse them. That's easy. You don't have to crack anything.
Remember that Ranger is the security module, and there is a SQL injection on the login.
On that interface. Now quickly, Mahdi, Cloudera.
Yes, we already talked about before on the Cloudera U, which is often installed on the edge node, which is accessible by every user. That we showed the scheme before, and there is a vulnerability, which is that the u.ini configuration file is readable for 21, other.
Yeah, 21.
So you can just steal the credential of the database and then steal the cookie on the database that we show. We have the session cookie. We can just take it and reuse it in order to access the administration interface of you.
And the mitigation is to unset the permission, or not, more importantly, not to deploy you, because this is a web application. You don't have to deploy web application on the edge node, because an edge node is like a client, deported client, and you don't have to install web application on the side of an edge node. That's a bad design. But we now have the vision. It was not really clear for us, but now it's clear. Don't install anything except Hadoop clients, Hadoop HDFS -FS or whatever. No other application. No other application. And in the end, our maybe last but not least, high technical, high skilled attack, our most elite attack is that for a Debize cluster, that command tries to find any GitHub accessible on read for other, And in real life, it gives you that kind of results. We developed a slight theory. We're pretty scientists. In a gray box attack with only one profile accessing an edge node or a server with a simple profile, no privileges, just with this command, you will collect and you will be able to access 80% of the data lake because people misuse keytabs.
They don't know what is this. They don't know that keytabs is pretty much the same as a password, so that they just store the file with read for other.
Read for other writes, and so as a defender, please put in place some detection measure in order to see if there are some keytabs accessible to anyone. That's really a strong measure, again, besides the simple authentication. Just put in place some detective control because people will do and will misuse keytabs. No read for other, please. So now if you also want to start hunting for vulnerabilities with us, get on the boat with us. And as installing Hadoop could be a challenge, use a prepackaged environment, which is really easy to install. This is just a standalone virtual machine. As the demo we perform are in standalone machine. Get on the boat with us, try to find some stuff, and make the thing happen for Hadoop security. Everything we presented today, everything, every vuln, every stuff are published. Okay, 2 minutes are published on our GitHub. Please, we are really eager for some feedback and some contribution. Please. Now, taking a step back, that you can see that the security maturity of that ecosystem. Hadoop is not a technology built upon security. No encryption by default, no real authentication by default. Then you have a fragmented ecosystem. Apache Ranger is only accessible and packaged for Hortonworks stuff. There's a lot of immaturity in secure development. You have a lot of classical vulnerabilities, even for security modules. And you have a complex operational security because people will misuse Kerberos file.
So, some simple recommendations. So first and most important, carry out your cluster because, like we showed you, if you don't carry out the cluster, you will have no security on your Kerberos cluster. Then reduce the service exposition. We have seen that the services are very verbose. They expose sensitive information and sensitive data. So you have to reduce the exposition. Then don't give a free shell if a data scientist does not have the right to launch your yarn job. Do not allow us to do it. Then deploy the application. No, do not deploy application on edge node. For example, that you have seen it's affected by vulnerability. Then try to prevent and detect the misuse of Kerberos keytab. It's very important because we have seen a lot of cluster Kerberized, but with a lot of keytabs available for everyone. And then try to harden. It's, I think, the most difficult recommendation. Try to harden components and try to keep up to date your cluster. It will be a challenge to keep up to date because it's a big issue, but you have to do it. So thank you.
That's all for us, Paul. Thank you for being here. Don't hesitate to give us your feedback and continue the discussion and start the discussion on scale.com. And thank you. Thank you very much.